always do the slides for histology. All right, so this is trachea. This is the lumen of the trachea, this space that's right here, and the giveaway is that this is a pseudostratified ciliated columnar epithelium, and so if you go to high power, you see that. So nuclei at a number of different levels present here, and there are cilia on the surface. If you go to the highest power, we can see that. All right, so now then, we're going to move in an anterior direction. Posterior is up towards the top of the screen as we look at this. Anterior direction, we're going to come out, and what we'll run into is, if we look on where we have trachea, so this is pseudostratified ciliated columnar epithelium, and then hyaline cartilage, which is the hyaline cartilage that is going to be down here in the thyroid cartilage of the larynx, or it's also in the tracheal cartilages that we find. And they're C-shaped. They don't go around and connect on the posterior side. Only one cartilage all the way down our respiratory system is a complete circle of cartilage. So feel the big one in the front of your neck, that's tracheal cartilage. And it only goes about 60% of the way around, so it only goes to the side. The one right below it is really small in front, it's big behind, and that's the one that's completely circular all the way around, and that's called the cricoid cartilage, and we'll see that when we well, you can actually see it on the model over there, but we'll see that when we do our discussion in lecture. So there's the lumen of the trachea. We're coming this way, coming across some fat and some mucus glands, and now all of a sudden we're going to run into cartilage. So there's hyaline cartilage right there, and that's what it says. We have hyaline cartilage, and the perichondrium is the connective tissue that's around this that has potentially stem cells, and on this side you see it best. Right here. So there's the perichondrium, and that's the hyaline cartilage. Now, I'll go back to lower power. There is a muscle that holds this C-shaped cartilage ring together on the posterior side. It's called the trachealis muscle. So I can go up either side here, and we'll see that. So here I am in the cartilage, and it's in the center of the screen, and we're coming up like this. Cartilage ends right here, and then there's a smooth muscle right there. That's the trachealis muscle. I'll go up in power and we'll see the nuclei, the smooth muscle cells. And the trachealis muscle extends from the end of the cartilage here to the end of the cartilage over on this side. So the cartilage went around like this, and the muscle sits between the two. And you can see the nuclei of smooth muscle cells within. Now, what this will do is that trachealis muscle will contract if we want to cough up something. It will allow us to force out more air. And another thing to note, and you don't see it here, but sitting right here where the trachealis muscle is, immediately posterior to it, that's where your esophagus is. And when you are swallowing something, you can't take a breath because the epiglottis is closed over the entrance into your trachea. And what happens is this muscle relaxes, and the esophagus actually pushes the trachealis muscle into the lumen of the trachea to take advantage of that space, because the esophagus is always closed. There's no reason to keep it open when you're only swallowing something for an aggregate of a few minutes a day. Okay, so that is trachea. So now let's look at, and I got a sequence. Let's look at the islet of Langerhans. Not the islet of Langerhans. We'll look at the pancreas. We want to see acinar cells. We saw islet of Langerhans before, and we looked at it right here. It's the light staining region. But 90% of what we see here are acinar cells. And an acinus is, if we were to look at it, it looks like it's pie-shaped. There's a little duct in the center, and the cells are kind of pyramidal, like I'm trying to draw. The nucleus always sits back here at the base. And usually it's darker staining out here because there's a lot of ribosomes and rough ER, because you're making proteins. You're making the digestive proteins that are going to go into your small intestine. So it looks dark to the outside, and it looks light towards the center. And that ductule is so small, and usually it collapses, so we really don't see an opening. It shows us that. microbes, the islet of Langerhans that we looked at. As you look at this, notice they're all dark around the outside and they're light towards the center. Dark around the outside, light towards the center. The nucleus stains, because nucleic acid stain, the dye that's used here is called hematoxylin and eosin. Eosin gives the pink color to the stain, to the stain section, and the hematoxylin gives the dark color. Well, as we look at this, so here's one of those pie-shaped acids, that's an acinus. There's a nucleus, there's one here, there's one there. It's all dark around the outside, it's light towards the center. Because all you have there is you just have stored the granules that contain protein, and the protein stains light. Same kind of thing here, dark around the outside, light to the center. Dark around the outside, light towards the center. So that's an acinus. All right, now I'm going to jump down and we'll do female reproductive system. And we've got 4 things to look at there. And we'll talk about these today in lecture. So this actually comes from a rabbit ovary, so you'll see many more follicles developing than occur in a female ovary during a cycle. So we have 3 different types of follicles we want to see. We want to see a primordial follicle, a primary follicle, and a secondary follicle. The primordial is, in human females, it's the one that she was born with. It was already in place and it started into the first meiotic division when she was born, and then it's arrested until after she's become sexually mature, and we're going to mature some of those cells. And as we look at them here, it looks like a little black dot with a white circle around it. And we have several right over here. So that's the primordial follicle. Then you know, bringing this in line with the development in the human female, monthly after she's passed through puberty, she's going to start about 30 to 35 of these towards maturation, although she typically only is going to ovulate one. You start a great number towards maturation because they have to make a hormone to get the whole process going, and one doesn't make enough hormone. So they become a primary follicle, and the primary follicle looks almost like it's oval with a bunch of columnar cells around it. So there are 3 of them right there. That's primary follicle. Okay, so here's one right here. So the primordial follicle, like this guy, has developed in this. We don't see the nucleus within it, but we're starting to get these cuboidal to columnar shaped cells. They'll become more columnar as development occurs. And there's another one here. We do see where the nucleus of that follicle cell is. There's another one right here. So that is primary. So the primordial is the black dot with a white circle around it. Primary looks like this with the cuboidal to columnar shaped cells around it. It's gotten bigger. And then the secondary follicle is the one that's getting ready to be ovulated, and you pick it out because there's this half-moon shaped space there that's filled with fluid. And what will happen is, at the time the ovulation approaches, a hormone will be released that causes smooth muscle around the outside to squeeze. And when you squeeze on that follicle, there's no place for that pressure to go, and the fluid's going to cause the oocyte to be pushed out of the wall of the ovary. And that's what we're going to see right down here. So here, this now is a secondary follicle, and it's gotten bigger. All the cells around it are called nurse cells. You know, this is the C-shaped space referred to as an antrum, and it has fluid in it. And so what will happen is, at the time of ovulation, the hormone release, it's called luteinizing hormone. We'll talk about it today. It's going to cause some smooth muscle out here to contract. It puts pressure on this non-compressible fluid in this space, and it forces that cell out through the wall, and that's when ovulation occurs. Now, all of the cells that are present here, they're all called nurse cells. They're just helping with the process. Some of them are going to go along with the oocyte and sit around it and protect it when it goes out in the oviduct. But some stay behind, and they become a temporary endocrine gland that's called the corpus luteum, and it produces a hormone that is necessary to keep the process going up until and if fertilization occurs, as we see, and this is the corpus luteum, meaning yellow body. And if if there is not a fertilization and implantation, at least in human females, then this dies off after about 12 days or so, and it becomes a white scar in the ovary, and it's called the corpus albicans, meaning the white body. And so one could actually take from the human female, could take an ovary, section it, count the number of white scars, and see how many ovulations have occurred in her lifetime. So there's one there, but there's another one over here because this is a rabbit. So there are multiple events of these taking place. All right, now we'll look at male reproductive. And again, we'll talk about this today. So the tube we see here is a single tube sitting in one little compartment. It's called the seminiferous tubule, and it's very, very long. And what it does is it winds back and forth. So it's back and forth and back and forth and back and forth in the compartment. And when you cut it, it looks like there's a whole bunch of tubes there, but it's all a single tube, and that's where sperm cells will be formed. So that's the seminiferous tubule within the testes. And that's the lumen of the seminiferous tubule right here. The dark profiles that we see sticking to the inside, those are the tails of the sperm cells. So the head of the sperm cells is sitting out here, and it's being nourished by a cell that's called the Sertoli cell. I won't try to point it out to you, but we will. I'll talk about it in the lecture. So the heads of the sperm cells are kind of bullet-shaped, and they're sitting right here, and they're associated with these cells. These are all the tails. Those are the flagella of the sperm cells, and they're sticking out into the lumen of the seminiferous tubule. And the other structure that we're interested in is called the interstitial cells of Leydig, and they're the ones that are producing testosterone. And so they are the cells outside of the tubules, and we actually don't have this space in real life. Everything is just kind of pulled away. But you see a grouping of cells outside here, and a grouping there, and one out here. The ones on the outside, those are the interstitial cells of Leydig. Okay, so they are the ones that are going to produce testosterone. All right. So we'll see those again. Now I'm going to go back and I'm going to do from the tongue down to the liver. And it'll leave just two slides you haven't seen. And that'll be lung and kidney. We'll finish everything for exam number 4 today. And then next Monday and Wednesday we'll do lung, so I'll probably show you lung. And then we'll do kidney as soon as we can thereafter. All right, so here's the tongue that we saw before. And those are fungiform, block-shaped papillae on the surface of the tongue. That's going to be the lumen of the oral cavity, stratified, squamous, non-keratinized epithelium, and we have taste buds along the side. And as I've shown when I've gone to higher power, showing this before, you can't see taste 4. And I mentioned that on page 8. Taste 4 is not seen, but it'll be just along the side. So the taste buds are not sticking up into the cavity. They're kind of nestled between a couple of taste buds. So there's, excuse me. Oh, I'm going to show you filiform papillae here. So the filiform papillae are spiky looking, and they don't have any taste buds, and there they are. I mean, they're pretty non-glamorous, but there we see them. Those are the only two that we have that show that. So just as a contrast to the fungiform that have the taste buds on the side. Then we have esophagus with its stratified squamous non-keratinized epithelium. Cells are alive all the way to the surface, because the nuclei are all the way to the surface, multiple layers. And then we go over, because this says stomach-esophagus junction, and we run into